Okay, we got 2 weeks. We can do it. We can do it. All right. And so we're going to just today talk about the male genitalia and spermatogenesis, and then we'll be done with this for today, then we'll move on to female tomorrow. So when we talk about the reproductive structures of the male, and we're talking at this point, it's talking about the human male. It's not talking about all different species of male. We have the penis and the scrotum, and this is what we call the genitalia. But what are the gonads? There's genitalia and then there's gonads. What are gonads? It is reproductive, but when we say penis and scrotum, that's the genitalia. What are the male gonads? Testes. The male gonads are testes. Analogous characteristic for females are the ovaries. Okay, so there's a difference when we're talking about the reproductive system. Like the penis and the scrotum are external genitalia. Okay, although they're there, that doesn't necessarily mean, other than copulation, that they're going to be used. The actual sperm-producing organs of a male are his gonads, and those are his testes. Both of his gonads are held in the scrotum, which is outside the body, and there's a completely physiological reason for that. It's because if the gonads get too warm, the sperm denature. And what does denature mean? Not disintegrate. Change their shape, so they change their function. So the testes have to stay outside of the male's body because at 98 degrees, they denature. The scrotum allows them to stay cooler outside of his body. If his body gets really hot, the scrotum has two muscles, and you don't have to learn that in this class, but in anatomy we talk about it. It's two muscles, and if he gets hot, those muscles relax and allow the testes to pull away from his body so that they can stay cool. If he gets cold, those two muscles contract and pull the testes closer to his body so that they can stay homeostatic. So the function of the scrotum is to keep the temperature of the testes homeostatic. Yes, ma'am?
So what about if they're in a hot place, in a hot tub?
Yes, great question. So we are actually going to talk about spermatogenesis. And being in a hot tub for an extended period of time, 15 minutes or more, whether you're male or female, is not very good at all. So you should be there and then kind of get out for a few minutes, then get back in, then get out for a few minutes. In the event that you're producing sperm at that point, meaning you've hit puberty, the likelihood is that you stay in there for an extended period of time, the sperm that are currently there will denature. Okay? But the good thing about that is that as long as you don't fertilize during that time period, we don't have anything to worry about.
What happens if you do fertilize?
If you do fertilize and those sperm have denatured, there's a chance that, number one, the chromosome number will be off, or that there may be an issue. And it may cause the sperm count to go down. It really is just unique to that male how it's going to affect. But having the testes too hot will denature those sperm or cause some complications at some point.
So you said their function changes? Like, is there like a specific...
Not necessarily. So their function is to fertilize, and if they change their shape, they can't.
Okay.
Yes, so their function changes. They cannot fertilize. Yes,
So
ma'am.
if you're like pregnant, you're supposed to not be...
Yes, pregnant women shouldn't be in hot tubs. And that if in the event that you do, it's like 5 minutes in, and you get out. The issue with the hot tub is that it takes your basal body temperature. So our basal body temperature needs to be between 97 and 98 degrees. When you're in a hot tub, it literally starts to kind of boil your blood. Does that make sense? Like it heats you up. And that increases your metabolism, so you start to sweat. So it's trying to keep or maintain homeostasis. Well, the baby can't maintain homeostasis. It depends on the mom to do so. So being in a hot tub while you're pregnant is definitely not recommended. I'm sure people have done it, but it's definitely not recommended. There's a slew of things you're not supposed to do when you're pregnant. Good question. Okay, we are going to look at the anatomy of a testes today and talk about where spermatogenesis occurs. So spermatogenesis, Genesis tells you it is the beginning or the creation of, and spermato is telling you it's the creation of sperm. If the sperm is created today, it will take 6 to 8 weeks before it is capable of maturing and fertilizing. So sperm that start today won't be ready for 2 months, let's say, at the most / least. And we want it to take its time because we want it to be functioning Ideally, we want it to be structured, ideally, so that the offspring has the best benefit. Okay? We're going to talk about the seminiferous tubules, which I'll show you. Leydig cells, which are responsible for producing and excreting testosterone. And then Sertoli cells, which support spermatogenesis. I'm going to go to the picture first, and then I'm going to come back. So I'm going to walk you through kind of what happens, and then we'll go to the words. Because if I give you the words first, it's really hard to kind of understand how it all fits together. So what a male has, and this should be pretty consistent for male and female, we're bilaterally symmetric. So what we have on one side, we should have on the other, less our heart, which is to the left slightly. Okay, so a male has two separate gonads, two separate testes. This structure right here is called the epididymis. Sperm that is mature and ready to fertilize is housed here. Okay, so this is where the most mature sperm is. In the event that the male is going to ejaculate and those sperm will be released from his body, the sperm will travel up this tube right here, behind his bladder, so it goes behind, comes up here through the urethra and then exits his body. The sperm, if a male has a vasectomy, this is the part right here that is cut. And we talked about that the other day. So this is the part that's cut. So the male could still ejaculate, there would just be no sperm that made its way up there. There's a difference between sperm and semen. Sperm is the actual sperm that will fertilize. Semen is the sperm plus 3 secretions. So it's a mixture. Those sperm will travel up the vas deferens. This prostate gland will add secretions. Right here we have the bulbourethral gland. They will add secretions. And I missed the seminal vesicles. These two glands right here will add secretions. So we have 1, 2, 3 secretions that will add to the volume of semen. It does not become semen until we have all 4 components. So sperm by itself is sperm. Semen has 4 components. Okay? Here you can see the side profile. You have the testes. The mature sperm will be here in this structure called the epididymis. It will travel up behind the bladder. And here you can see the seminal vesicle here. You got your prostate and then your bulbourethral gland, and then it will exit the male's body. In the event that the male is going to ejaculate, the bulbourethral gland, before he ejaculates, will release a cleansing antimicrobial agent that will neutralize any urine that's here, because the male does use this urethra for both reproduction and for excretion, so excretory, so to release urine. So it's cleaned out before the semen makes its way down there, so that there's no toxicity or anything like that. There's no, there should be no issues. I'm going to show you another picture because we're talking about spermatogenesis. So inside of the testes, this is a cross section, and if you're in my anatomy class, I say it looks like ramen noodles, because to me that's exactly what this looks like. But sperm will start here, and as they mature, they get pushed here and into here, and then through ejaculation they'll leave in this way. Sperm do not swim in the male's body. They do not swim until they get into the female, her reproductive tract. So while they're in the male, they're not just like swimming around. There's so many of them, and they're packed so tightly that they do move, and there are cilia to help move them, but they're not like actively swimming, what we would call capacitated. So each of these little ramen noodles, here's a cross section of it. Every sperm starts from a stem cell on the very outside. So it will start here, and this is it blown up, okay? And as it goes through, it will divide, and it's showing you the division process. And then we have sperm that are almost mature. When they're completely mature, they will make their way to the lumen. Do you recall where the lumen is? It just means an opening, okay? So they will mature from the outside, and as soon as they're ready, they'll be here in the center. This whole process right here takes around 6 weeks, okay? Just going from there to here. And again, we want it to take its time. Then from there, it'll get pushed into this area, which we call the straight in the rete testes, and then it will come here to the epididymis, and then it will make its way out of that male's body in the event that he ejaculates. If he does not ejaculate, no sperm stay there, they will eventually disintegrate. Okay, so it's not like there can be 5 years of sperm just built up, but they will disintegrate because they run out of food source, and they can't live, so they disintegrate, and they'll end up peeing them out. The lymphatic system will clean them out. Trying to think of anything else I need to say there. Let me go back. Any questions so far? Go back and make sure I covered all the material. Okay. Sperm are released into the lumen, and again, the lumen is just the opening, that hole of the seminiferous tubules. Then they will move to the epididymis. Then from the epididymis, which is right there on the top of the testes where all the mature sperm were, and that's what I pointed out at the beginning, they'll be pushed through the vas deferens, leading to the ejaculatory duct, and eventually the urethra exiting the male's body. Semen has fluid and sperm. So the sperm is, of course, a component, but then we have fluid from the seminal vesicles, the bulbourethral glands, and the prostate gland. Why are these both alkaline fluids? Alkaline mean basic. Why does semen need to be basic? Urine is acidic. The vagina is acidic. The female vagina is designed to kill the sperm on contact. It wants nothing to do with it. When we watched that video last week, and you saw her immune system kind of fighting it, and it even said at the very beginning, it showed those sperm, once they hit the acidity of the female vagina, they denatured immediately. It was just way too acidic. Her body is designed to kill the sperm. Okay? So when a male ejaculates, it's important that that semen is slightly alkaline so that it can neutralize that acidity and give the sperm in the core a chance to ascend the reproductive tract. Obviously it works or we wouldn't be here. Okay? Obviously it does. Because sometimes people are like, well, how does that work? It obviously does. Okay? And that's why it's called the miracle of life, because all this has to happen simultaneously in a nice stream of events in order for someone to be conceived. What questions do you have right now, if any? Okay. Testosterone is the male sexual hormone. And I'm going to show you a diagram here in a moment. I just want to point out the words that we're going to look for. GnRH. It's a hormone. It's called gonadotropin releasing hormone. A male begins to mature or hits puberty because his brain tells him it's time. So the brain is what initiates all of this. So the gonadotropin releasing hormone will be released, and then that will stimulate the release of follicle stimulating hormone and luteinizing hormone. Follicle stimulating hormone will make the sperm. Luteinizing hormone will make testosterone. Follicle stimulating will make the sperm. Luteinizing will make the testosterone. Okay? What does testosterone do? For a male, first of all, when testosterone levels, when he is growing inside his mom, his testosterone levels are high for him to become a boy, and then they drop off. Right after he's born, in between like a year and birth and about a year, there's a small surge of testosterone, but then it kind of stays low. And he just has his normal growth. When a boy hits puberty, his levels of testosterone skyrocket, and they're kind of like shaky for a year or two. By the end of 3 years, they should be pretty consistent, testosterone-wise. Okay? So he has a spurt of testosterone while he's developing in his mom, so he becomes a boy. A little one right after he's born, and then it kind of just lays low. And then once he hits puberty, it's going to skyrocket up. It takes about 3 years, and then it maintains a plateau-ish. That's textbook. You could have a problem or issues with hormones, and then, of course, that doesn't work out. But the whole purpose of testosterone, its functions, it stimulates spermatogenesis, which is the creation of sperm. A male does not start to make sperm until he hits puberty. His testosterone levels have to be high enough in order for him to produce sperm. The testosterone also allows for the male's reproductive tract to mature and his external genitalia during puberty. It also stimulates the development of secondary sexual characteristics. Secondary sexual characteristics include body hair, an increase in odor, oils that are left, facial hair, axillary hair, pubic hair, muscle mass, fat deposits. These are all aspects of secondary sexual characteristics that we see in males. And going across different species, because of course it is biology, but like horns on bulls, they don't start developing until the testosterone levels in that bull are high enough. Same thing with bright feathers on peacocks. We see the same thing when we look at the mallard ducks. We talked about that earlier on in 1406. So testosterone allows the boys to develop like boys. Questions? Okay, this is where I went. So, do you remember what negative feedback is? We studied this in 1406, negative feedback. There was negative feedback and positive feedback. We're supposed to maintain homeostasis, right? In the event that we're hungry, we are not homeostatic. Tell me what happens. Someone starts to growl. What else happens? You feel it. You feel that you're hungry, and so what do? You go eat to bring yourself back to homeostasis. That's what negative feedback says. Negative feedback says we have a problem, we fix it. We know what homeostasis is supposed to be, and if we feel off, like we have a muscle cramp, or we have a headache, or we're hungry, or we're tired, our homeostatic levels are off. So we need to correct them. That's what negative feedback says. For men and women, their sexual hormones are controlled by negative feedback. So, I told you that when men hit puberty, it's controlled by the brain, specifically the hypothalamus, releases GnRH. GnRH is gonadotropin releasing hormone. That hormone affects the anterior pituitary gland. The anterior pituitary gland is still in the brain. Pituitary gland. And it allows for the release of two hormones, follicle stimulating and luteinizing. What will follicle stimulating make? Sperm. What will luteinizing hormone make? Testosterone. Okay, so we started with the brain, hypothalamus, gonadotropin releasing hormone stimulated the anterior pituitary. Anterior pituitary releases follicle stimulating, which will allow for sperm to be made, and luteinizing, which will allow for testosterone to be created. What if testosterone levels get too high? So here's homeostasis. What if your testosterone levels get too high? What does your body say? Do they like that? No, your body does not like it. Your body does not like it. So it will immediately stop producing testosterone until your testosterone levels get homeostatic again. If the number of sperm are too high, your body does not like that. So it will slow the process of creating sperm in order to maintain homeostasis. We see this problem happening with men who use anabolic steroids all the time. Testosterone supplements, we see it happening all the time. Your body produces enough testosterone to maintain homeostasis. When you take a supplement, it increases your blood levels of testosterone, and what does that tell your brain? There's too much. So what does your brain do? It stops making it. So then whenever your body cycles out that pill, that supplement that you took, your testosterone levels drop. Tell me how that male feels. Drained. Completely drained. We see this similar pattern happening with females because their hormones naturally fluctuate, but men are supposed to plateau. So he's drained. Tell me what he does. Takes another supplement, brings him back up. When he does this for so long, it sends a message to his brain that says, you have plenty of testosterone. I don't need to make it anymore. This also causes rages in these men because their hormones fluctuate. So they feel really, really good, feel really, really bad, feel really, really and you'll often hear when people are under the influence of steroids or anabolic steroids, they call it a rage. We also see a whole lot of acne consistent with puberty. You might be 38 years old, but your face is covered in acne and so is your back. That tells us that your hormone levels are not homeostatic. So the male's body tries to maintain homeostasis. If he takes those steroids, it will stop producing that testosterone and he'll fluctuate. Now, when we get to females, we'll say something similar, but females naturally fluctuate. So their mood swings are completely justifiable by the fact that their hormones are up, and then within 24 hours they go from being really high to really low, and she's like, I don't know what's wrong. We don't really see that in healthy males that don't take supplements. We see that they have high testosterone levels, they remain homeostatic, and they just plateau. They're just nice and stable. It is not for any random reason that they say women are crazy and men can be more laid back. Women are crazy because their hormones fluctuate a lot. Men, plateau. Okay, so that's all actually physiological. So follicle stimulating is the sperm themselves. Luteinizing is for the testosterone. And we see, when a male hits puberty, those hormone levels peak, and then they should plateau off after around 3 years. Questions on this? So we did male reproductive.
What are the Sertoli cells?
Sertoli cells are supporting cells found within the seminiferous tubules, the testicles, and that are supporting the development of the sperm. They help to maintain homeostasis there. The Leydig cells are the name of the cells that will secrete the testosterone. So these are all supporting cells for sperm development. Other questions? All right, that's where we're going to stop. Did you? Oh, sorry.
So pretty much it's kind of pointless for people like your guys to take steroids because it just like messes up their production of testosterone.
It does mess up their production of testosterone. There are men that take steroids for various reasons. Not all of them are so that they can get super ripped and bulky. Some of them are justifiable in their usage, even though they're not good for their body. I will say this. It is pretty much across the board understood to people who actually study what happens, that if you start to take steroids, you cycle them. You don't just take it every single day for a year and then drop off. You cycle it for a few weeks and cycle off, allowing your body to kind of come back. But with that comes those hormonal fluctuations. You never just straight do something. We see this mistake not happening necessarily with testosterone, but with like antidepressants. A lot of our population has been prescribed antidepressants. So these people take these antidepressants for 2 or 3 years and then decide, I don't want to take it anymore, I feel fine, I don't need it. And as soon as they drop off of them, we see that their body can't make up for what it should be doing. So that's using something other than testosterone, but to kind of see what happens there. Other questions? Good question. It's not pointless. Steroids aren't pointless if they're used